All right, Theta exercise 1.02, question 7. It says, show that triangle PQR with vertices, they're the corners, P, Q, and R. Oh, that's meant to be R, I think. R. That's R. Not a very good R, is it? R, which is 5, 1, is an isosceles triangle. Name the pair of equal sides. So let's have a shot at this. The way I would actually do this is to try and work out which sides are equal by observation, and then try and confirm that as best I can using the distance formula in coordinate geometry. So here is my. I'm going to have a shot at drawing this out, and it's going to be a little bit hit and miss. I'm not going to get it very accurate. I don't suppose. That's my y, my x. So we're told we've got the sides 5, so we've got 2, 7. So I'm going to say this is 1, 2, and then you've got 1, 2, 3, 4, 5, 6, 7. So 2, 7 is going to be about there. And that's P. And I won't bother putting 2, 7 there. We can just say that point is P. Q is going to be negative 1, 1. So it's going to be 1, 1. It's going to be there. And that's going to be my Q point. And then I've got the other point there, which is R, which is 1, 2, 3, 4, 5, 1, which is going to be there. And there's R. So we've got a triangle that looks roughly like this. And I say roughly because it really is kind of a very poor sketch in a way. All right. Well, it almost looks equilateral. But if I was a betting person, I would say that PQ is the same length as PR. And then this is the base of the isosceles triangle. So I think these two look like they're the equal ones. You could argue these two were equal or these two were equal. But we're going to have to take a guess. So let's guess. And certainly if I was drawing this out to make life easy, I'd just make these two the same, and I'd have that as the base. I think that's probably what they've done, but let's find out. So we've got some detail here to put in. So I'm going to write here the distance of line segment PQ. I'm going to write the detail in here. I've got negative 1, 1, and I've got put a comma in between and a 2, 7. That's the detail for the distance there, which I'm going to insert into the distance formula. The distance formula is the square root of, it's going to be x2 minus x1 all squared plus y2 minus y1 all squared also. So let's throw all that in first. Let's see where we end up. So we've got the square root of x2. I'm going to call this x1. Call this y1. This is x2. This is y2. All right, let's get a sharper pencil so I can actually write this stuff. Okay, so x2 is going to be a 2 minus an x1, which is going to be a negative 1. That's all squared plus a y2. Well, y2 is 7 minus a y1, which is a 1, all squared. Okay, let's see what happens. So I've got the square root of, well, 2 minus 1, 2 minus minus 1, sorry, is a 2 plus 1, which is 3. 3 squared is 9 plus 7 minus 1 is 6. 6 squared is 36. So I'm going to end up with 9 and 36, which is 45. Now, I'm actually not going to bother solving that. I'm just going to leave it as root 45, which is fine. And we can actually simplify that, if we wanted. But I'm actually going to leave that just for now because it doesn't say find the lengths of the sides. It just says show which two are isosceles. So if another one is the same length, then we know it's isosceles. Of course, if they're all the same length, then it's equilateral. But it says that we're going to show that it is isosceles. So I'm going to go with that. That's my distance of PQ. Let's now find, I'll put the D of PR. Here we go, distance of line PR. And I'm going to throw in the numbers here. So P is, where's PR? 2, oh wait, PR. If I'm going to keep P the same, actually. I'm going to put P at 2, 7. PQ. What did I do here? Oh, I left one of the same. So I'll leave this one the same. So this is The other coordinate then is going to be, what is it, 5, comma 1. So 5, comma 1. That's not very good writing, but anyway, you get the idea. So I'm going to call this one x1, this one y1, this is x2, this is y2. Sorry, I'm just getting mixed up with which bits am I going to call what. But at the end of the day, as long as you have got the stuff you down you need, it doesn't matter which order these go in, provided you are consistent with this being an x1 and these are all 1s, these are all 2s in terms of the x's and the y's. Okay, so here we go. So the distance of this thing from here to here, because remember, you can't have a negative distance, so it doesn't matter which order you do it in. You can have a negative direction, just not a negative distance. So I've got x2 minus x1. You can choose which order they go in. y2 minus y1, all squared, is equal to, now, let's see where we end up. We've got a y2, so straight away we're going to have, what's that going to be? 2 minus 5 all squared plus 7 minus 1. Is that right? 7 minus 1. And we ended also with 7 minus 1 as well with the other one. Okay, so this is equal to, well, straight away I can see that this is going to be 2 minus 5 is going to be negative 3. Negative 3 squared is going to be positive 9. And I've got 7 minus 1 is 6. 6 squared is 36. So I'm ended up in exactly the same place. So because the length of PR and the length of PQ are the same, therefore it must be isosceles, providing the other one isn't the same as well. And I think we can assume it's not going to be the same simply because it says it's isosceles. So we can put here a big, therefore, we can put length of PQ equals, what put here, PR. And I think that is a reasonable proof for the question.